a rather intriguing tool. I think you'll agree when you kind of see what it is capable of, and just a little bit of housekeeping. Like we said, we've got parking passes and such, so come let us know if you need one of those. We've got there was some interest expressed last time in the possibility of doing some open source contribution stuff. So if anybody is interested in doing that, let us know. We need to get a better picture of kind of what direction we were going. We were discussing a little bit earlier some of the previous things we had done in that realm pre-pandemic, and so we are looking into what are our options going forward. Kind of what's the interest, because like the direction you would take with that kind of thing is going to be somewhat dependent on what are the skill levels and interest. You know, what's the goal of doing that. But we would be very happy to help get things going. Again, always looking for more speakers. If we've got if you've got an idea you'd like to present on it, we have people who have quite a bit of experience setting up talks over the years for various user groups. So we would be happy to help you get something together. Just reach out. We've got a few people on deck in that realm. We've got a few others. We've got some ideas for some Go presentations that we're trying to get the logistics together. I think we may be good through the end of the year, but we would definitely, into next year, we're definitely going to have some openings. So if anybody is interested, please reach out, and we'd be happy to get you up here. So anything else before we get started with HD?
I would just say, like, if you're interested in doing a talk, but you don't want to do a 40-minute talk or 50-minute or 30-minute, and you have a 5-minute thing, that's cool too. Like, please, like, you have a cool thing you worked on and you want to share it, that's all great stuff. Like, so talks don't need to be super fancy, but just need to be something that you care about and you want to share everywhere else.
Yeah, absolutely, absolutely. We've definitely on many occasions had like a night of nothing but lightning talks. Those actually tend to be some of the best nights, and so, you know, by all means. So yeah. All right. Well, let's have HD come up. All right. Thank you.
It's kind of a fun talk for Go because not only is the tool we wrote to do the TAC in Go, but we also attached a lot of Go tools with it. So we have CVEs and 2 different Go packages as a result of the work. But first, we're going to kind of take a little bit of a detour. So just for familiarity, who here uses SSH? Probably a lot of people, right? For SSH, who here uses public keys for auth as opposed to cool? So a lot of folks use it. So a lot of this is going to be focused on like SSH pub keys, OpenSH itself, all of the buzzing. I'm going to go pretty quick for a lot of the SSH content, and probably we'll spend more time with the Go content. But let me know if you guys want to see more or less of anything. How to go faster or slower. So this whole thing kicked off.
What is Run Zero?
What's that?
What is Run Zero?
Oh yeah, sorry. Run Zero is a company I started 5 years ago. We find all your stuff. So we identify all your assets on network, cloud, on-prem, anywhere in between. We put them all together in one big thing, and you know, it's great. And also we've got a free version for the home lab stuff, so it's a great way to send out and monitor all your stuff. The thing that we're like probably best known for is we'll send a very tiny amount of network traffic and tell you precisely what all your stuff is without credentials. So we do super deep fingerprinting, all kinds of weird like inference stuff like that. We'll use things like the TCP window size plus your SSH banner plus something else to like fingerprint the exact kernel version of like Rocky Linux remotely, and say, oh, and because it's this version, we got this one. So it's a really neat way to like learn a lot about your environment without actually having credentials or access to it. So we're really popular for pen testers, but also for like M&A and for folks that are going to an environment where they don't have a lot of direct control over it, like a university, for example. So basically, the worse your network is, the better we are for it in most cases.
How is it different from TCP dump? Because like TCP dump, I think it also shows like just based on the headers, it shows you like OS fingerprinting and things like that, right?
Yeah, so TCP dump will show you like the packets and OUI mapping for the MAC and stuff like that. What we do is like active scanning and passive listening, and we also connect all your different integration sources like your cloud providers and tie them together. So we will grab like your EDR data from CrowdStrike, tie that to your Azure backend, tie that to your IAM, tie that to everything else, and then overlay that with your role management data and the network scan data and your passive data. So kind of like a 15 perspective analysis of your environment. But I don't want to be a pitch for Run Zero. So my company, it's a lot of fun to play with it. We got a free version, but now we're gonna talk about happy stuff. So this all started off with the XE Utils backdoor earlier this year. Was anyone else kind of scrambling when this came out? Just to see, okay. So someone managed to basically backdoor SSH on Debian and RHEL-based distros. They only managed to backdoor the ones that were in the lower distributions, like Tumbleweed and the testing versions. But only because we got really lucky, only because somebody basically found the backdoor while they're doing performance assessment or performance analysis, trying to figure why SSH is using a slightly different CPU. The really neat thing about this backdoor is that it was like a 3-year con. So somebody basically joined the open source community, made lots of contributions, used sock puppet accounts to basically bully someone to give them ownership of the project, and then use that to slowly introduce the backdoor through multiple commits. So they added the payload through one commit that looked innocuous, then they added a way to trigger the payload through a different thing, and they finally added the way that the thing tied it all together wasn't even the source code, it was only in the release terminal. So it wasn't even triggered until you actually tried to build the thing, and then only on the platforms that would distribute devs and RPMs. So really nasty backdoor and really mean to the open source maintainer. Like the guy was already having kind of a mental health crisis, and everything else was happening on top of it, and the guy was like bullying him for multiple fake accounts, like really nasty all the way around. The backdoor is really interesting too in that it was what we call a nobody but us backdoor, in that the person who created the backdoor is the only person who can use it. They did that by tying it to an encryption key where they have the private key and then the public key was part of the backdoor. So if you don't have the private key for the backdoor, you can't abuse the bug. So it smells a lot like nation state just because of how well it was done. So the persona that was used for this backdoor process was Gia10 on GitHub, or Gia-T45, something like that was the name, or Gia10T45. So we thought it'd be interesting to go figure out who this person was, right? Like, can we go find the person who did this multi-year state-sponsored backdoor, right? So where in the world is Gia10? It's kind of where we started off. So we decided to go hunting. So Gia10 targeted SSH with XE Utils backdoor. So we're going to target Gia10 with SSH. So one of the things a lot of folks don't realize about SSH is that SSH servers will tell you whether or not your key is allowed to authenticate, even if you don't have the private key. So if you have someone's public key for SSH and you go to an SSH server and says, hey, can user Jim log into the server with his public key, the server will say, yeah, you can. Now prove that you have that key. But it'll also say, yeah, you can first. And that's really interesting in this case because that allows us to confirm whether a particular user has access to a particular server if you have the public key. Which, yes, sir?
Is it considered like a bug, or is it like supposed to be this way, or like what is the thing?
That's OpenStation's comment for the last 20 years. They're like, send a reply, is this okay? I don't know, this seems like a bad idea, but whatever. So this whole mechanism of like, send the public key first, get a PQO key back, an OP back, then do the verification, is kind of been part of the protocols that Wobbly did for a long time.
So I think GitHub, like it used to let you see like the user, like all the public keys that the user has in their account. Do they still let you have that, or did they fix that?
We're getting to it. So, you can see where this is going now. So the idea is like, because all SSH servers by their specification allow you to confirm whether a key has access to an account, you can see things fit. So we added a module that's put forward back in 2012. So if you have someone's public key, you can figure out what they have access to. Now, one of the ways you can use that, of course, is let's say someone's running Nessus on the network and using pub key authentication to authenticate to your machines for Nessus generation. You can take the pub key that they send you, save it to disk, turn around, take that public key, and then scan all the machines on the local network and see what could Nessus actually log into. So you're able to determine what the inbound credential has outbound access to, basically. So you can kind of flip the script on the authentication side. So, let's see. Sorry, there's a slide you copied the wrong spot. Sorry about that. So like you mentioned, GitHub stores all your public keys on the internet. So if you go to your user handle.keys on GitHub, it'll dump all the pub keys you've uploaded. And people have been crawling the database for years, building a database of all the GitHub users and all their public keys for a very long time. So this 2018 dump had about 4.3 million keys. There's about 117 million GitHub users right now. You can get a list of all the usernames through the BigQuery API backend, and then you just crawl and grab all of them together. So we decided to go grab Gia10's keys, and then basically go see what Gia10 could access on the whole internet. So first, step one, grab the keys. Step two, scan all the internet, looking for anything running SSH, and try to authenticate as Gia10 using the pub key to it and see whether it accepts the key or not, with a bunch of random usernames that we thought would be valid for this Gia10 persona, like root, admin, GAT45, things like that. So we had a company's tool called Shamble for it, which was the little Go-based tool to basically do this pub key half-off. So normally when you use an SSH client, you don't have the ability to do a half authentication. You can't just like take someone's public key and turn it off. It just doesn't work. SSH client will say, no, where's your registered key? But if you build your own custom SSH client, you can basically use half authentication attempts. So you start off using building this thing that we call Shamble as a half-auth scanner. It's a really fast way to check the whole internet for a given key really quickly. This is our poor DigitalOcean node just melting away in the background. We destroyed so many VMs there, just grinding away. Scanning SSH is like really painful because you have to do full key exchange every time. So every server you're doing a full-on like SSH handshake, Diffie Hellman, and all that kind of fun stuff. So it's super terrible on the CPU side. So you can see we've already sent about 411 gigabytes of SSH traffic just doing handshakes, and we're all about halfway down in the screenshot.
So do you think, how long does it take? Does it take like maybe like 2 seconds, or like how long does it take like in one CPU at 100% or whatever?
For one server or for many servers?
Yeah, for one server.
It's like less than a second. It's just that we're doing 27 million of them across lots of usernames and then lots of ports. So it ends up being the kind of common drawer loading is really big, basically.
Well, usually like when I try to authenticate, it usually takes like a minimum of like 2 seconds, right? So is it?
Depends on the stage of what you're doing. So there's a bunch of phase authentication. The stuff that we're doing here doesn't even get to that stage. We're doing all this stuff well before you have a slow one happen. So there's the CPU intensive part is the key exchange, then you get the authentication. Authentication is where you have mandatory delays in the protocol. So when SSH feels like it's slow to authenticate, it's not because it's actually slow on the CPU side, it's because it's intentionally delaying the authentication process as part of the way it does like anti-username discovery and things like that.
I guess, is Shamble configured so that you can just do that one step like you said? Or did you have to?
It's got a million different modes in it, so you can say just do everything, or you can say just do the PubKey half-off scan.
Yeah.
Or you can tell it to go, you just basically get shells on the internet and half-off. So you can do everything in between. It's a great way to like randomly get shells and everything. One downside though of our scan is that because we try to authenticate to everything on the internet as geotan, now every server that logs the key thinks we are geotan. So we basically like, self-identified ourselves as the bad actor to everyone in the whole world. So we're still expecting the law enforcement folks to show up and be like, hey, are you guys, no, we're not, I swear.
Hopefully you're not running from your house, right?
No, it's pretty shit, but it's my credit card, it's my company, right? So they'll find me if they really want to, but anyways, the downside is, like, we found a bunch of results, but all the results were false positives. And some of them were actually, like Charlie was mentioning earlier, memory corruption bugs. We saw a server where, like, every 5th or 6th time we authenticated with a key would accept it. And we're like, what's going on? And we started, like, just doing GET requests to the web server of the same machine, and it was returning random corrupted memory. So it just had such janky RAM that it's just, like, letting you log in around half the time. And it's, like, bugs like that. So we found tons of broken servers, lots of screenshots. We kept fixing bugs, so we'd have to say, like, well, pick, generate 3 random SSH keys, try 3 random ones in a row. If all 3 of those are rejected, try the geotan key. Now try 3 more random keys afterwards, and if all those all in the right order, then we know the middle one's actually accepted, then we're good. So we built all this random crap trying to make sure that they weren't false positives in testing. Got all the way to the end, 3 days later without sleep that weekend, and like, crap, we did not find a geotan. They've got really good OPSEC. Good job, China, or my sugar bullets, right? Now the fun part though was that in the process we found 110,000 shells. So we managed to actually root a huge ton of bunch of internet. So the tool we wrote for doing this testing accidentally found all these off-bypass bugs. So that's actually where all this work came out, is like, we kept finding all these fun ways to basically break into servers accidentally as part of the search. So you mentioned earlier, like, GitHub will show your pub key, but also Launchpad.net has been developed a portal, you get the pub keys off that. We've installed Ubuntu recently, it'll actually let you import your SSH identity directly from GitHub. So it used to be public keys were like a private thing. Even though it's called public, you weren't like sharing it with your friends. It wasn't like a PGP key. But now that everyone is doing development in the open, you're generally sharing your SSH pub key with the world all the time, unless you take some steps to avoid that. So this kind of changes the game a little bit. If you ever want to see this trick, you can SSH to whoami.repo.io, and it will actually say who you are based on your GitHub key, using a reverse look of your key through hash. Yes, sir.
Was that like a lucky thing that we started looking at his SSH key, public key, and it was happened to be the one that he was using? Because I normally would not use my GitHub one for something like that. Actually, we have a.
We never found it, right? So
okay.
We never found the person.
Okay.
So they did not actually use a key anywhere in the world.
Okay.
We never found it.
Well, I think like basically if it's a fake name, then like why would they have like any other account with the same fake name, right?
Well, we're hoping to have like a root ad or something like that, where they have a VPS or a bounce server someplace. We really just want to find some server they had access to, and use that as the first step to dox them, basically.
Yeah, so the public key thing was actually news to me. So how does that, you know how like GitHub has its CLI stuff and it handles everything in the CLI now?
Yeah.
Like, is it the same, does it still use public key?
No,
or-
GitHub will use HTTPS and OAuth tokens for everything by default these days.
Okay.
So, unless if you're using Git and you say, I don't wanna use SH anymore because it makes me cry, then you just use a little Git rewrite ref rule that turns all your SH URLs into HTTPS URLs, and then it'll use the GitHub OAuth instead. So there's like I forgot the Git command offhand, but if you ever run problems doing like private repo checkouts with a GitHub command line, you just switch that little SH to HTTPS rule.
Like instead of.
Yeah, instead of rolling Git. So that's a way to like avoid using SH, but I mean, so many folks upload your SH key to GitHub, right? And as a result, like people are just making giant databases of them. What do you mean? So, there's all kinds of fun things you can do with database keys beyond this too. That'll be a separate talk. But yes, this is a fun server. This is run by Filippo, who runs like he's the maintainer for the X crypto portion of Go. So he's currently implementing all the post-quantum crypto stuff right now for the Go stack. It's really pretty cool to see his work. So I love all the stuff he does. He's got this really cool server that basically doxes you and the SH into it, telling you who you are, which is really cool. So putting it all together. So if you want to like find whether a user has access to a particular server, you need to go scan the internet, find all the SH servers. It can be done in ways, Masscan, Zmap, etc. Zmap on a DigitalOcean node that'll cost you about $15 to run per day. It does in about 2 hours for finding all the open ports for one single port in IPv4, covering about 3.7 million addressable IPv4 addresses. And there's about 27 million that respond on SSH, and of those only about 12 million, 14 million will get to authentication phase. So it's really not that many targets when you start slicing through it all. Then there's V6 and all kind of stuff. That gives you a pretty good starting point. You can also just dump it all out, show in your census, or one of these other third-party sites that tracks existing SSH servers. So then you go get a list of giant keys to try. So you go grab GitHub keys, grab your Launchpad, or Bad Keys project by Hanno Bach. He's been building a list of compromised keys, so if someone's using a key that's known to be weak already, you can just use that key to log in, you know, try to keep that way. Then lastly, you need to know a username to try. So you try root, you try EC2 user or Ubuntu for cloud providers. What's also fun about GitHub keys is they don't scrub the comment field from the key. So if you generate a key on your local machine and we upload it to GitHub, and then GitHub, you download back from GitHub, it's gonna have your local hostname and your local username in that key in the comment. So now you know what username to go after. The SH comments are a really good way to target your time. Then you go find their email addresses, you understand like open source docs and stuff. So, you know, this is kind of like the duck size horse size duck problem. If we want to try one key on 1 million servers, how do we do that really quickly? Well, it's not too bad. You know, you just connect all the servers, try exactly one authentication attempt for the key, and it's pretty fast, so not a big deal. Let's say you want to go the other direction. Say you want to take like 117 million GitHub user keys and try them on one server. How would you do that quickly? Well, SH doesn't want you to do that because it's intended to not let you do this type of thing. So it has max off tries, which means after a few number of attempts it'll kick you off. So if you ever made a mistake that more than 4 keys to your SH engine, then you try to SH to any OpenSH server, you get like too many off attempts and disconnect it before you get a chance to authenticate to it. That's because you're getting max off tries with your pub key attempts before you can authenticate. And that's a little bit different because you're not even trying to authenticate all the way, you're really just saying, will you accept this key? And OpenSH is treating the will you accept the key as an authentication attempt, even though you haven't done the full authentication yet. Now what's different about that is, or what's interesting about that is not all servers work that way. So while OpenSH will treat a half-off attempt as a failed off attempt, the other 10% of the world doesn't, including Dropbear, which is the second biggest, or most commonly found server, including all these commercial products like FreshFTP, GlobalScape, all these commercial file transfer products, all these embedded, networking devices. None of these folks actually rate limit off attempts to half off.
But I think that sounds like a vulnerability, like in like Dropbear.
Yeah. So I know I'm gonna care, and I don't care either. So. So the example of this, we took the 4.6 million GitHub keys from 2018, where you can run them through at about 10,000 per second on a Dropbear machine on a single connection. So if you do, normally you can do 15 connections at a time on Dropbear as a default. You can basically grind 100,000 keys per second on a Dropbear machine. It doesn't even barely touch the CPU, even on like an embedded OpenWRT or another box. So if you're trying to figure out like, does anyone in the whole world with GitHub have access to this stupid SH server running Dropbear? You can figure it out in like 3 minutes or 8 minutes in this case. At least the 4 million keys. And you need to divide them by connection accounts. You can really get it down to like about 10 minutes for all of GitHub really quickly. So one of the things Shamble does now is let you basically brute force billions of keys per second against SH servers that don't implement half off data attempt tracking. Now, by comparison, if you do the same thing for OpenSH, it'll take 10 hours. This is limited to about 132 connection attempts per second before you get disconnected, now to reconnect, and so on. So So effectively, SH or OpenSH is using the connection limit and the maximum authentication temp per connection as the way to do it. What's interesting about both these attacks, though, is that in the orange on the bottom, that's the only log you get. So we just tried 5 million keys on a dropper instance, and you get one log saying exit before auth. It doesn't track anything. So same thing over here. Like OpenSH doesn't track any of the failed attempts either. So there's not a whole lot of artifacts on the machine if you try these attacks. And even though you're trying millions of keys, it doesn't really use much CPU on the server. Because once you've done the key exchange, you're just saying like, do you accept this binary die says yes, no, real quick. So it's actually really efficient to brute force millions of keys and drop error even on embedded devices. So a really neat way to, anyways. So that's kind of a long detour to the geotan, doxing, key thing. It didn't work, but we found lots of shells, so now we're talking about shells. So about 27 million devices with IPv4 port 22 open at any given time, 14 million with negotiate SH authentication. Another, 13 odd million, less than that. Those are machines that they were running honeypot, they didn't actually be a banner, they timed out, they're broken, they're out of memory, something was broken with them, they weren't actually real SH servers. And if you look at like where we actually landed after running this across the internet, we got 110,000 random shells. Like, why did we get 110,000 random shells? Like, we're not trying to get shells, we just got shells. So what is all the shells we got? One's up, a lot of products will drop you to a shell even before you authenticate. So Sonic Wall is a good example of that. There's a few other ones out there. The thing that's bad about that is most of the security of OpenSH happens before you authenticate. Once you authenticate, you've got this massive attack surface. So you can do all these different commands that are not a shell. You can get a shell, of course, you can run a command, you can send a request, you can send environment variables, you can set agent forwarding, port forwarding, all the normal cool SH features. That all happens like before the shell even opens, after authentication. So if you've got a product that drops you to a shell without authenticating, and then makes you authenticate again through the shell itself, you can now attack all these other things on that shell before it gets there. So digging into it a little bit.
Wait, do they actually let you do like port forwarding, like to
We'll get to it.
To any host on the internet?
We'll get to it. I swear. So examples like Sonic Wall, Juniper, and Ruckus in this case. So you're doing SH to the device, it's authenticating on the SH side, dropping into a shell, and then you can authenticate again interactively. So even though it looks like it's making a lot of your SH, really you're already past the SH place, and now you're actually going to interact with shell on the process of the device. And this is where you can do neat things like signal injection. So OpenSH, so SH as a protocol allows you to send a signal to a remote process, including in this case the login shell of these things. So OpenSH were restricted to really common, boring ones like SIG-Hub and things like that, like pretty safe ones. But Dropper doesn't. You just send a SIG-Seg via SIG board. So in this case, we're connecting to a device. He's giving us a login prompt. We're like, how about a SEG mofo? And it goes blah, and it just basically aborts and dies and drops a core. So you can do terrible things to process. So even though OpenSH freestanding above with signal reentrance, the regression vulnerability, this isn't even signal reentrance. This is just like signals all day long. You just like match signals in whatever process you want because that's how the protocol works. So we've been finding all kinds of fun ways to use signal handling, pre-authentication, post-SSH authentication, pre-shell authentication to basically hammer weird bugs on these different services. Now on the forwarding side, you guys know how port forwarding works, we'll go into it. But you see port forwarding is a type of channel you have over OpenSH. So there's a lot of cases where you get this post-SSH off pre-login shell, and they did not turn off port forwarding. So we went and just tried port forwarding across the whole internet real quick for fun, and see what can we actually port forward on. So here's an example of like an ION network service access point. We tried to port forward to google.com, and it says, no, we can't do that. Okay, whatever. We'll try like a random IP address real quick. So we'll try just like connecting 888. Nah, it doesn't like that either. Let's try going to loopback, see what happens. Well, we can actually like hit the loopback port. So we can actually use port forwarding to target other services on the same network device. And this particular device has a Redis server bound to loopback that does authentication. So you use port forwarding pre-authentication to port forward Redis, then dump Redis out of the device, which happens to change the password for the device, then you then log into the device.
Nice.
So one of the really dumb bugs you can use. Basically, port forwarding in this case became off bypass because that worked.
But it's also like when you connect to localhost from localhost, then you also get extra permissions, right? So for example, like for SMTP, right, you can send mail.
Yeah.
You cannot send mail from like the internet.
All your apples that depend on localhost, like your Redis, your MySQL, your Mongo, all that stuff just lets you write in, right? Because you're localhost. So even Postgres cases, you can enable no auth from loopback. So some other fun bugs we found, like the Ruckus access points. Yes, sir?
You said port forwarding became what again? Back. There's a specific word I've never heard before, or I guess term in networking.
Loopback, why?
Loopback, was it?
Oh yeah, so loopback is like the IP address that's assigned to your own machine. So every time you connect to 127.0.0.0.1, it's only talking to your own computer. It doesn't go, it never leaves your device, right? So in this case, we're doing a port forwarding to the local host address of the remote device. So we're talking to services that would normally only allow the own systems often. So we're bypassing like network apples, things like that, by doing port forwarding through the system to it.
It's basically a synonym for a local host, right?
Yeah, local host or loopback. It's technically like all of 127/8 is down to loopback. So you ever see like 127.1.1.1 or 127.0.0.1, they're all the same thing. You can actually use all those other 127s, even though there's a whole effort right now on the internet to repurpose them to free them up for other users for assignments. It's never gonna happen. Just like T23 and all that stuff, or T24 up.
I think they're not all of them are actually like assigned.
Well, it's all reserved, but
Right.
reserved but not assigned, I guess is the right way to say it. Another fun bug is like the roster access points. When you connect to it through SSH, it basically lets you log into SSH without a password, then drops you to a real authentication shell. Then it says type your username, type your password. You type in, instead of your password, you type in echo-n, $, echo, blah, blah, blah. Or sorry, you type in $, whatever shell command you want, and redirect out to standard error, and it just runs the command as root, because it's actually doing echo command in the back end to SHA-256 to get the hash to get your password. But they put it in double quotes and single quotes, so of course it's a shell injection. What's really weird about this particular bug is like there's 900 of these things still remotely exploitable on the internet right last week. Like how the hell this bug that's like super trivial lasts this long? Like these are enterprise access points cost like $5,000 each. Like how do people end up with this many of them still unpatched? Runs up the vendor fixed the bug silently, didn't tell me about it, and of course no one applied the patch because they didn't have a reason to. So out of the 30,000 odd machines that we found that are exposed to the internet, 900 are still exploitable, and there's still no CD for it. So we're actually going to use the local hacker group, AHA. They're actually a CNA now for CVE. So they're going to assign a CVE for this bug, so that we can actually get people to care about it.
So did you get the credit for it? Did you get the credit for it?
No, this is already fixed, right?
Right.
I mean, I don't care about credit. I care about shells. So like, I'm actually very happy.
Well, but like you're running a company like as a business, right? Like so don't you want to get like credit?
That's my day job, you know. But this is research. This is fun. No, I'm actually kind of relieved whenever I find a bug that's already been patched that I don't have to do all this disclosure, crap. Like, it takes so long to do the whole process of like notifying people and waiting 9 days. Like, if they say it's fixed, like, great, I'm gonna put it on Twitter. Thank you. Like, you guys said it's fixed. There's no disclosure needed at this point. So.
Well, but people, I think like the idea there is like if people are vulnerable, then you're still not supposed to like disclose it, right?
But the vendor knew about it. They didn't tell their customers.
Right. Well, that's the general procedure that many vendors follow still. So
yeah, I mean that's why we just dropped 0 day all day. That's what so like, that was the goal.
Well, I'm saying like aren't you supposed to like worry about the customers because like it's not like the vendor doesn't really kind of like it's not the vendor that exposes their customers, right?
Yeah,
so like
I do worry about the customers. That's why you have to disclose it. The vendor didn't tell them. Like in this case, the vendor already did it wrong. Like the only thing you can do at this point is let them know that they're exploitable. Like I didn't break the bug.
Well, so that's why you do the CE thing, right? So.
Whatever. It's more formality at this point. Like, no, CVEs are their own mess today. The Linux kernel project decided that they got tired of people asking them to report every small bug as a vulnerability, so they started reporting every single bug as a vulnerability. So the Linux kernel project is now doing like 100,000 CVEs a year, just as an FU to the CVE because they got hammered so much on not disclosing security fixes. So it's turned into this whole political thing and stuff. But here's a show.
So that's why the numbers are so big now because they used to be small and
it's all Linux kernel. Just dumping it like it was what's his name? Yeah, it was. I agree with their approach. I think it's hilarious, but it is kind of shows you what's happening. In CVE, of course, is the NVD group of CVE fell behind by about 8 months, so there's been no enrichment of vulnerabilities until recently. They found it hard to find a contractor to catch up on it, but it's a whole other thing. So another fun thing we can do with SH is set environment variables pre-shell. So if you ever like, if you speak French and when you shell into your computer, you want the computer you shell into to have a French language set, then you set your lang variable to be FR, then FR give 8. You set that as your send end variable in OpenSH, you connect your server, and then you log in, you have all your great French localized output, right? This goes terribly wrong. So there's lots of really cool projects out there like Dogs, Git, Fortshow, Garrett, basically hosted kind of Git servers, and a lot of these are actually written in Go, like Dogs, Git, and Fortshow are all written in Go. There's also, you know, your big forges like GitHub, GitLab, Bitbucket, but a lot of these are actually written to go in the back end. Like GitLab's SSH daemons are written to go for committing over SSH. Then you have these really cool libraries like Charmbase SSH, Apache Nino, which is a Java-based library, and you know, some examples of what those look like here. So even if you have really secure code on the Go side, you can actually get bit by other problems. So for example, GitLab, Git, and Forge show all only allow a single environment variable to be sent during the SSH session, which is Git underscore protocol. And the Git binary is really careful that it only does very limited things with that protocol. So it'll never, it only parse the version parameter, you can't really do injecting thing. However, if you built those programs with an older version of Go, you can inject whatever you want to it, but we can nullify another variable afterwards. So this bug was fixed in Go 1.19.3. So even though your source code in Go is secure, your Go library, your Go build chain was out of date, and therefore you can introduce vulnerability. So this is one of the reasons like I religiously update every security update to our product. Every time there's a Go update, we ship a product update immediately. Because those security bugs, we may not know what the impact of it is at the time, we know there'll be an impact eventually. So we really try to like ship security fixes to the Go build chain into our product binaries like this happen. Because things like this happen, right? We get like random environment injections that it doesn't mean anything until someone finds a bug that you're on. Then all of a sudden all your stuff's exploitable because you didn't upgrade your build chain. So if you're running like Go 1.16, like don't try to run the new version because you're gonna have all these other random vulnerabilities in your code. I was using a product called Wiz recently, which is it's kind of like a cloud vuln scanner. It takes your drive images and scans them for vulns. And it reported that our CloudWatch agents had remotely exploited vulnerabilities in the Go library. We're like, really? What the hell? What's going on? We finally realized that for some subset of images we're managing, the CloudWatch agent binary was not being updated. The binaries had been compiled with like Go 1.12. Like it was massively years out of date, right? So they had all these vulnerabilities in the TLS stack, all the DOS bugs, and they weren't really directly exploitable, but like just gives you a sense like people are shipping ancient binaries right now. They're shipping binaries that built ancient versions of the Go build chain and not considering a vulnerability by not rebuilding the binary. If you're a Go developer, you need to know that your Go build chain is part of your vulnerability exposure. If there's a vulnerability in Go, you've got to fix your binaries and ship them again. You can't just patch your app. You actually have to build new stuff and ship it. Otherwise, all your binaries are now affected by these downstream bugs.
So the solution to that would be like to distribute stuff in source code, right?
Well, solution for who, I guess? Like your customers don't want source code.
Okay.
I mean, you could, I guess, but like, I mean, end of the day, like, you know, you just need to keep your binaries up to date. If you're distributing binaries, you gotta keep them current. Otherwise, you have these like weird bugs that are second order effects that don't trigger until all the stars align and now all your customers are on.
We use Trivy for scanning.
Oh, Trivy?
Yeah.
Is that like static analyzer or is that like a dependency analyzer?
I don't know the exact.
It's a SaaS. It's a static analyzer.
Got it. Cool.
What's the difference?
One looks at like, are your dependencies out of date? And one looks at, is your code securely written? And not doing things like putting variables into a system command and things like that. So one looks for like programming flaws and one looks for vulnerable dependencies in your chain.
So static would be vulnerable dependencies in your chain?
Static is usually your code itself be that. So like you're doing something in your code that's not secure.
Oh. And what was the other one?
Like Dependabot.
Dependabot.
Yeah, Truffle. And there's secret scanners too, like Trufflehog and the GitHub secret plug. So there's a couple of ways you can do it. Kind of the 3 CI tools is really how your SAS tool, which is your SAT, SAST, which is your static analyzer, your dependency analyzer to make sure that none of your dependencies have vulnerability, and then another tool that goes off and runs your secret scanner to make sure you don't have an embedded secret in your binary someplace. You're not shipping like part 30 keys someplace.
Yeah.
So these bugs, these are kind of minor, right? This bug in 1.19.3 only applied to Windows. So it wasn't that big of a deal. No one's running Git on Windows that often, so it wasn't too much of an issue. However, we started looking at GOGs. Has anyone used GOGs before? Yeah, GOGs is really cool. Yeah, when it first came out, it was like mind blowing. It was like an entire GitHub is a single binary written in Go and it did everything out of the box. It's really cool. Have the web portal, you can self-register, you can set up a Git repo, you can issues, all kinds of cool stuff. Then it was semi-abandoned, right? Like the folks forked GOGs into Git got forked into Forge Show. Like those projects took off. The GOGs developers kind of like didn't really have their website, didn't really, shut down here. So we're looking into the GOGs code as part of this audit, and we found that they've got their code for handling environment variables, which is really broken. Like normally when you set an environment variable, you set the environment variable in the process, and then you set it in the sub-process. So you set the environment variable for like language, for example. Then you run the command, the shell, and now the shell has the language variable. In this case, they're running the env command in a subprocess, but that didn't do anything at all. It didn't actually affect the parent process, so it doesn't affect the process you run afterwards. They're effectively just running env binary for no reason. It had 0 side effects. So they just didn't know what they're doing, unfortunately. Like, I don't want to dump on them, but like, this kind of looked like a backdoor. The reason for that is like the env command actually has a little trick to it where normally env is used to set, variable to value. But if you give it the -s command, it actually treats it as it then parses the substring like another chain of commands, and it runs whatever command is on the end of it. So you can just embed random commands into it. So effectively this exec command function in dogs is just a straight up exec, code exec. Whatever command you want, you just throw it there and run it as the server. And because you can self-register in dogs, you just create a temporary account, self-register, and then get the shell. So, and it doesn't actually do anything. It doesn't actually set the environment variable, so it just looks like a backdoor. So we reported this bug, I think in April, and the developer never responded. We got to give it a GitHub advisory for it, but never got accepted. And then another company called Sonar Source published an advisory saying, oh yeah, we reported it. They reported it 2 days before us. And they just gave up and the developer published it too. So there's still lots of ODA sitting in God.
And the point, it does sound like a backdoor, right? Because if it wasn't a backdoor, they would fix it. And like, if they don't want to fix a backdoor, then it means it is a backdoor, right?
The dev is just depressed and doesn't want to work on it anymore.
Okay.
So I think they just like, yeah, that was my mistake, and I feel bad about it, but
It's like another company. He's like doing for fun, and I've seen a bunch of situations like that. Like they just whatever.
yeah. But
Yeah.
it feels like you don't really know when that happens to a project. You don't really know when it gets abandoned like that. So it's a shame that like this thing's not full of bugs, but the website doesn't say anything about it. If you go to dogs.io right now, it says we're a great tool, please use this. It's like unless you know that it's actually full of backdoors,
Yeah.
So anyways, it's unfortunate.
So how would you like as a user, how would you know like if things like that exist for like a product that you want to use?
You gotta test it, you gotta look for it. I mean, it's open source, you gotta look at the dependencies. The challenge with auditing a lot of this stuff in Go is that the bugs aren't even in the source code. Bugs are in the dependency, below the dependency, right? So the bug we're about to talk about a little bit further on here is in,
but in this case, like it's like a project that like it looks like it's alive, but in reality, like it has a backdoor that like the developer doesn't want to fix. Like, how do you find that?
Look at the GitHub issue count. If it's like 5,000 and nobody's responding a year, like just go somewhere else. Like do not engage. It's a trash fire. Or if it turned off issues is also a good warning sign. So if you look at how like other servers handle environment variables, like Apache Mina and Garrett, for example, what they do is they only look for very specific environment variables. So the Apache Mina library, which is the SH library in Java, doesn't actually filter which environment variable it accepts. It'll pass everything through to the caller. So now instead of auditing the library, you have to audit every single user of the library, make sure they're using environment variables correctly, which is a huge pain in the ass. It took us months. So we're going through like every single tool that ever used Apache Mina with SH and auditing all the freaking code. So I've read all these libraries like front and back now. But if you look at like what environment variables they actually use, they only use Git protocol and environment column, so it's pretty safe. Like you can eventually just do a graph of the code of like what environment variables you're actually gonna process, and not a whole lot, right? So it was pretty safe. The other thing about this is that JGit, the Java-based code repos don't actually call the Git binaries. They call an internal Java implementation of Git, which means they never create a sub-process. So even if you do set a terrible environment variable, it doesn't really matter because you're not actually running a sub-process, never really gets applied anything. Now, in contrast, there's a really cool library called Charm Bracelet, or the Charm Bracelet SSH, which is the fork of Glider Labs SSH, which is son of Xcrypto SSH, or whatever you want to call it, but basically, like, it's all derivatives and wrappers around the Xcrypto SSH code and Go. But Charm Bracelet SSH is like a way to basically write full-featured, interactive terminal UI programs over SSH using the Bubble T kind of framework and all the stuff they make. SoftServe is like their equivalent of Dogs. It's a really neat little software repo manager. You basically set up with a directory, you can like SH into it and like navigate repos, create issues. It's kind of like a GitHub UI server SH only. It's really neat tool. It looks really pretty. However, they screw all kinds of things up. So they accept all environment variables, and they also run a Git sub process, and the combination is basically a straight remote shell. So we found a really neat way to snap it together. Ends up the easiest way to exploit this was using Git LFS. Git LFS, the large file support, lets you add an arbitrary reference to the Git repo, and the Git repo file name on the remote side is predictable based on SHA-256 of the content. So in this case, we created a shellcode binary, just a little like run bin shell shared library. It's called an init. we basically created an account by default in this soft serve instance. We use get LFS to upload the library, the .so file to the repo, and then we LD preloaded that through SSH, and then made the remote server LD preload our shared library and dropped it to a command shell basically. And now we've got a remote shell on soft serve. So that affects every single thing using Glider Labs SSH and Charm Bracelet SSH. That doesn't filter the environment when we get to it. So even though the bug in this particular case was in the soft serve, it actually affects everything else that doesn't parse environment rules. It doesn't filter environment rules when we get there. It's a really fun chain of bugs to exploit it. Anyway, so rambling a bit about that, but the short version is like Go programs are definitely not immune to these kinds of bugs, right? If you take random environment variables and then you run a command, obviously there's lots of room to screw it up. Or you run the env command for the reason you've got a backdoor. I want to shift over to talk about SSH's protocol a little bit. So SSH is super complicated. You've got all these different states when you get into it. The very first thing you connect to SSH will get like an SH-20- your banner name, like OpenSH-92, whatever. If you were netcat at port 22 or ran SSH client with -VVVV, you'll see like all this stuff during the exchange. But the very first thing you see is the birth exchange. Then you see the key initialization, the kex in it. And that includes things like what ciphers you support, compression algorithms, things like that. Then you do your like Diffie-Hellman or Ethereum exchange, kind of like your TLS handshake. And then these are actually do your authentication. And finally, once you get past your authentication, now you're in what they call larval session stage, which is you've authenticated, but you haven't actually opened a channel yet. And a channel would be considered a port forward or a shell or some other thing you're actually doing with SSH. So that's kind of how it's supposed to work. It's actually fairly secure in terms of how it works, in that you're only allowed to run certain commands in the protocol level at each state. So before you've done the kex, you are not only allowed to do commands 1 through 9. When you're in the user auth stage, you can only do commands 0 through 79. When you're in the all these different flavors of bracketed protocol numbers. So the protocol itself has ranges of message IDs you're allowed to send based on what authentication stage you're in. What's also interesting about it is OpenSH and Dropbear are even more strict. They create a big handler table in their C code saying for this ID call this function. And as you transfer between state to state, they remap the narrative. They clear out all the handlers every time. So there's no way to accidentally get to like a shell state when you're in the pre-auth state, because the function just doesn't exist in the handler table. So they do a really good job to make sure that they're kind of like belt and suspenders for exploitation. So that's how it's supposed to work. A while back in 2018, there's a bug in C code called libSSH. libSSH and most SSH fibers both clients and servers, because the protocol's so intermixed. The client's basically a server and vice versa half the time. So libSSH had a fun bug where instead of the client saying I authenticate, the server saying yes you've authenticated, the client could say yes I've authenticated, and the server said cool, and then you have a shell. So a really neat bug. So basically you just said like give me a shell after I told you I've authenticated, and it said okay, you get a shell. So we're like that's a really cool bug. Let's do that for like in every single phase of the protocol. So we created a custom SSH implementation based on crypto SSH from Go, and we basically at every single individual stage of SSH handshake, we just demanded a shell. We're like, I don't care what state you're in, give me a shell. How about now? How about now? How about now? How about now? All the way through. And it works. The crap was the shells. So one of the fun ones we got was these digi transport gateways, little industrial control routers. Was really weird about these is we spend months trying to reproduce them. We're working with the Bug Crowd platform group, working with Digi International, and they could not reproduce the damn thing. It drove us crazy. We're like, we have like 100 fewer customers right now with shells in their machines. Like, we know it works. They're like, yeah, but we're in the lab, we can't reproduce it. Ends up it was a uninitialized variable. So in the global heap of the program, it says, have you SSH'd in before successfully? And if you hadn't, it would randomly let you in and randomly wouldn't let you in. If you had successfully authenticated before and then disconnected, it would clear that bit and you wouldn't be able to connect to it again because it says you're not authenticated. But in that pre-authentication state, it was kind of like up to wherever the bits were, how to be initialization. So it's one of those like funny kind of bit flip almost bugs where depending on whatever memory state the device is in on boot, you could authenticate in without a password randomly. And it took forever to nail it down because the very first thing our vendor contact did for every device was SSH into it, set the debugger, then say, now we're trying your attack, it's not working. It's because they SSH'd in that they broke the attack. So that took forever to nail down a lot of Zoom calls and it was annoying.
Well, but like, why would they say that it's not working? Like, it's their problem, it's not working, they can debug it, but like, they can verify that it is working, right?
Well, we gave them our like full exploit code, and they're like, okay, we're trying it internally in the lab, we cannot get it to work. I was like, but look, all these shells on the internet, like, we just hacked out your customers by accident, like, it definitely works. Like, we give them serial numbers to those customers, go talk to it. So it was really painful because of the bug. We finally figured out what it was, and then we're kind of like slapped there for it, we're like, oh my god, uninitialized variable, okay, makes sense. Another set of bugs with these Realtek routers is,
So how do you like, if you get the root shells from like those customers, how do you get their permission, for that, or like, how do you not get in trouble for doing that?
it's internet. I mean, we weren't trying to get a shell, we accidentally got a shell.
I've seen that, because we also have a procedure in our company, like I've seen that some companies who do research, they do have their IP the researcher name.
Oh, yeah.
It's kind of their authorized, right? They at least tell who's doing that. That's
Or
a
you mean like
research.
the RDNS or whatever?
If you do like a who is for the IP, sometimes actually
Okay.
comes back with the name of the researchers, but
They
you can
show
actually
it.
directly call them. Like there's a whole, yeah.
Yeah, we all set ours to Microsoft.
Yeah.
Okay. There was, people think a lot too.
Yeah.
It's fun.
Some are legit actually. Some are actually people we check.
Yeah. So another series of bugs were the Realtek routers. A bunch of these like Realtek makes a bunch of like, you know, SDKs and chips and silicon, and they license the SDK to a bunch of vendors to then build equipment around it, like DSL routers and things like that. So you'll see a router branded Neverbit or Netis or one of these random names, and really it's just a Realtek chipset with SDK, very light customization, a couple logos on it, and that's pretty much it. So we found tons and tons of these devices exposed where you just shell them without a password by bypassing the state, and we couldn't figure out who to contact. Realtek didn't respond. None of the individual vendors that had their logo on the device responded. So we just gave up, still zero. So have fun. Similar, we found two models of Panasonic switches that would let you in to add them without a password. We couldn't figure out how to report it either. It's all in Japanese. Like the normal Panasonic site is all in English, but if you try to report anything around the networking equipment, it's only Japanese. And we sent a bunch of emails in and no one got a response, so kind of gave up on that too. So those are still exploitable. So examples of shelling those real quick. These are the Realtek based router. This was a Neverbit that's really popular in Iran. It says like, I don't know, probably 15,000 of these things on the internet in Iran. In this case, we're using the shamble shells with the first PTY, and then basically just dropping straight in. And then we're going to type in the show info command or show status command to prove that, hey, we got a shell this thing. Here's an example of digitransport. This is the uninitialized variable bug. So basically shell in, and now we're basically dropped into, welcome, your access is super. So, feel super. So it's pretty funny like how simple these bugs are. Now you just like run channel and get a shell and these things. It's great. Anyway, so quick detour. Sorry if this is going a little long here. I'll try to hurry up. So OpenSH is not, so SH is not OpenSH, and OpenSH is not just OpenSH. So OpenSH is a million different variants of it depending on what OS you're using. So if you're using, like we went and diffed every variant of OpenSH across every platform. So Mac, for example, we went to like the Apple fork of OpenSH and said, okay, based on the upstream OpenSH portable and then the Mac OS version of that, what did they change? Like what did they, molest basically? What terrible things did they do to the source code? Mac OS is not bad at all. They did very limited changes to it. They only enabled like keychain, PCS helper, endpoint event logging. It's pretty clean. So OpenSH for Mac is actually pretty good. It's about as close to upstream as you can get, including for Linux. Way better than Linux. Debian, Ubuntu, and Red Hat Linux, we call those XeUtils compatible, or backdoor compatible, because they've got so many freaking patches that link to all kinds of their random libraries. The only reason that Debian, Ubuntu, and Red Hat were targeted, or were able to be targeted by the XeUtils backdoor, is because they loaded systemd's libraries that loaded libxz. And there's no reason why SH actually uses libxz at all, it just got a transitory dependency into it. So Debian has like 36 plus patches, and Ubuntu as well. Red Hat is like 60 plus patches. So you're not getting OpenSH anymore. You're getting like some cooked weird variant of SH with who knows what in it. It's also this really neat variant of SH called PKIX, which is forked off of OpenSH in 2002 for FIP support X509, and it kind of sort of follows OpenSH code. You can tell they hate each other. Like anytime OpenSH changes something, it'll be like very similar but different, but Spike will comment in another code base. And half the time they get the logic wrong, and it's like if not becomes if. We're like, did not do. Like, anyways, it doesn't make a lot of sense. But they were also affected by the regression vulnerability, and it's a major fork. Like literally every file has changed. It's super annoying to audit. Then we said, let's go look at the Windows version. So Windows has been shipping OpenSH in Windows since Windows 10, including an SH server. So let's go look at the whole code. Well, they took all the secure part out. They got rid of chroot. They got rid of like all the things that make secure shell mostly secure. They basically ripped out as far as making it compatible with Windows. So with massive number of difference, like 350 files were changed. It was PMAS to audit. It calls the LSA functions versus native auth. There's no fork, of course. They create a sub-process. Like all these things are different. This thing was actually still OpenSH for Windows is still affected by Terrapin, and they just haven't bothered to fix it, even though the code is right there. Like they just don't care.
Is there a source code for the Windows OpenSSH?
Yeah, it's part of the PowerShell repo on GitHub. So it's like github.com PowerShell OpenSSH is the repo for it. So we
So what
started
kind of, has anyone like audited what kind of telemetry, SSH telemetry they send?
Yeah. Good question. Funny you ask. Yeah, so it sends all your stuff back to Microsoft. Anytime anyone SSHs into your Windows server, that server then sends your client version and the server version back to Microsoft. It also sends things that are normally included in the secure transport, like your auth methods, things like that. It doesn't send your password, but it sends literally almost everything else coming across the wire. So your server is constantly spewing information about who's SSHing into it back to Microsoft through their telemetry backdoors, through their telemetry system. The good news is if you turn off telemetry in Windows through whatever tool you like for it, it also turns off your OpenSSH telemetry as well. But it's pretty gnarly that like people are just like accidentally sending all their SSH telemetry back to Microsoft. What's really interesting about this is because it includes the client version of the handshake, it knows about all the machines that are connecting to the machine. So it knows if you're using your Mac to connect to a Windows machine, they know you're using Mac. They actually know what version of Mac OS you're using based on the version you're sending. If you're using, you get a lot of really juicy information. Anytime you run a vulnerability scan, for example, you're seeing the Nessus scanner or whatever your scanner is talking to that server, they know you're using Nessus controlling now too. There's just a bajillion things you can infer about the data they're getting from that telemetry that is not really cool.
Wait, so how do you turn it off, you said?
There's a couple tools for it. There's a tool with like Shutup, O++ or something like that it just does a bunch of registry hacks. You can turn it off in a group policy as well. Effectively, you have to go like just fiddle with a bajillion registry entries that turns off all your telemetry, callbacks, Windows error reporting. I run that Windows Shutup O++ tool on all like gaming machines first thing just to disable all that crap on the get-go. But this is not the worst part. The worst part is this. So there's a tiny little function in OpenStage that's been there for 20 years about called timing safe bcomp. And this function is beautiful. It's like 4 lines of code. You really can't screw it up. All it does is like go through byte by byte, do an XOR of each byte, compare it to make sure that the values at the end are equal. So what's really cool about this is it compares 2 byte strings and it can tell you whether they're equal or not without leaking timing information about how long it took to compare them. So your normal string compare will say, well, this string is smaller than this one, or this string is different than that one. And based on how quickly it compares it, you can actually infer information about one of those values. And if you're trying to compare 2 secret values, you obviously don't want to leak any information back to the attacker. So instead, in OpenStage and many other crypto tools, they have these timing safe byte comparison functions. In the Go language, you see it called subtle. So you'll see like subtle compare, subtle dot whatever. Those are things that are designed to not leak time information compared to secret strings. So if you're doing like bearer token authentication, you typically want to use the timing safe comparison function, not strings contains or string has or equal sign, right? So all of our code, for example, we use the subtle functions for crypto and key comparisons as opposed to normal string operations because there is a timing leak even though it's not particularly significant these days. As a aside, the reason why it's not so good significant is that the all your vector instructions in assembly on newer chips are so wide now that you're actually comparing like 8 to 16 bytes at a time. So you don't want to, on 32-bit machines, you're actually only comparing 4 bytes at a time until you hit the vector instructions. So typically you're actually able to leak out timing 4 bytes at a time on a 32-bit machine. With 64-bit, and then you vector instructions, all your SSCE and all the other ones right now, you're comparing a huge portion of the code of the buffer at a time. So the timing leaks are less significant, but they still exist. But long story short, so the timing safe bcomp function is how you safely and securely compare 2 binary buffers without leaking time information and make sure that they're all equal. And it's super awesome. DJM, who wrote this, it's timing safe, it's efficient, secure, it's like 4 lines of code. And then Microsoft happens. And Microsoft made it carriage return blind feed compatible. So they decided to look for backbar and backend and treat it differently. And I was like, this is designed for crypto keys. Why the F are you looking at backbar backend sequences? Well, ends up they decided to use the timing safe bcomp function to parse a configuration file. And because it was different on Windows, because that CR backbar backend, not just the backend, they decided to backdoor the crypto function instead of fixing their parser. So they backdoored everything in Windows. They made this code no longer timing safe, a 1 byte out of bounds memory read, so you can leak bytes of memory from the backbar backend of the source buffer, and it's an unequal byte match. You can cause it to verify crypto keys that are not actually the same source as the one you supply. And the more backbar backends you can put in the source buffer, you can basically shove the real key out of it and have it compare against just your buffer instead. So they backdoored literally every single crypto function over this age in 2 lines of code while making it backbar backend compatible. And it affects literally everything. That checksum, every single SH packet post encryption has this function called against it through the SH conf function. It's just horrible. So unfortunately, well, fortunately, I guess for Microsoft, the attacker doesn't influence the first argument of this function, the B1 here. They only really affect B2 in most cases. So you can't really force backbar backend sequences to be in the source buffer, but you can. The way that we were able to trigger it but not exploit it was you just do a ton of SSH operations, and eventually you end up with you have a 1 in 65536 chance of getting a backbar backend sequence in your crypto operation as a great encryption output. So you just keep doing that enough times, and you eventually get into a sequence that pushes the buffer out a byte, and now you're doing an off by one read. But unfortunately, because of the way the buffers are aligned, you're only reading null bytes. There's no one to tell you very much. So it ended up being like basically a no-op. You couldn't really exploit it unless you can control the buffer better or trigger 1 in a 4 billion chance of getting 2 backbar backends, and you can read 1 byte, and it was annoying. So we reported to Microsoft, who spends more than $1 million annually in cybersecurity and employs more than 35 security experts, and they said, no, we're not going to fix it. That's cool. So we just put it on the internet. That's that. Alright. So, yeah, a little disappointing, but whatever. You win some, you lose them. So this whole talk is basically around the findings, but we really built a tool. The tool from where it goes, all open source. We did some really neat things with it. One of the cool things about it is it does like all these pre-authentication attacks, post-session attacks. It actually has timing analysis using a stats library. So we'll actually look at like if you try to brute force different usernames, we'll tell you whether those usernames respond differently timing-wise. And it's really painful because Organization Dropper actually have a gnarly way of doing user deterministic by username timing. So if you try to log in as root and you try to log in as root 1, you'll get 35 milliseconds and then 90 milliseconds. And it'll be consistent. Each time you do it, it'll be 30 milliseconds and then 90 milliseconds. But then if you restart the server, it'll be 15 milliseconds, 65 milliseconds for the same root 1. And so what they're doing is they're seeking a random number and then they're SHA-256 hash against it, and they're using that to drive a timing value. They're sleeping that amount of time based on deterministically based on your username, based on the secret source key. So that's their way of preventing you from identifying usernames is they have based on your username and a secret random value, they drive a amount of time to sleep effectively, which makes doing timing attacks something really annoying because you get lots of false positives that way. But we do find servers where that does not happen, right? Some of the commercial libraries do SSH don't do timing difference. We're able to, especially with like pub key attacks or pub key authentication, some of this devices, the file system access is really slow. So if you get a valid username, it does a file system access time, you know the user's valid, it takes too long to access the file system. So that's all baked into the tool as well if you want to try it. If you have a big list of pub keys, it'll try brute force them all. If you have a big list of passwords, it'll try all the passwords. And if you have any combination of these things, you can do it whatever you like. I just like running a local network and seeing what drops out. Half the time, you run it with shamble --interact, and you'll end up with a random shell or a computer on your network. Like, how did that happen? I don't know, but it's kind of cool. So it's really good at just like dropping random shell load systems on your network that are misconfigured or buggy. If you have a system that does post-auth login, like it allows you to SSH in with either as none or with a known pub key or private key, and then it does another sequence afterwards, this is really good for finding like port forwarding and all those other checks you can do against it. Here's the checks we have deployed so far. There's a whole bunch of them kind of baked in, and they're all on by default, except for the timing attack, I believe, is kind of slow. So you can grab from GitHub, it's all public there. You can run a little quick scan, you can dump out a JSON file. The one thing that's really cool about this is an interactive shell. So even before you normally get into the real shell of SSH, it'll get into the shamble shell. And from there you can do things like that. You can say, I want to set this environment variable and another environment variable, and let me try a port forward, all before you can start the shell and then run session. It lets you do things that like SSH can't do as a client. So you can do some really neat protocol attacks. They're really difficult to do otherwise. Like in this case, we're setting the, probably can't see it, but interact with the first session, get a PTY, set the LD debug equal all environment variable, then ask for a shell. And what's really fun about this is if you end up in a system where it's using glibc and it has a post-login shell, the very first thing you see instead of a login prompt is this giant dump of the LD output telling you like all your linking libraries are being used. So we have a check for it today where anytime we can get a session with pre-authentication, we'll try doing LD debug equal all and all these environment variables that causes giant balls of output to get spit out by the binary. And then we can fingerprint vulnerability without having to do really much more work. So some of the stuff here, some of the commands you can run, PTY, signal, TSP, you can export forwarding, breaks, you can send bytes to it automatically, you can script all that. So you can come up with a really cool attack, you can do all the command line script up in the shell and ship your exploit if you will like that. All the binaries are available on GitHub now. We're doing GitHub actions to build binaries now. We started adding add key support. Analyze, so effectively we look at all the pub keys we found, the host keys of the server, and we see whether there are known compromised keys through that keys project. And then lots of little small improvements in the last month or so since we released it, container support, things like that. Alright, so the thing I actually wanna talk about, sorry if we got this long, I'm not getting to it, is like, how do you actually build this crap? How do you actually build a custom SH library using the standard Lit and Go? So we forked Xcrypto SH, but anytime you ever, you know, what's the number one reason you don't fork a library? You gotta freaking maintain it. It's a pain in the butt, right? Especially if you're forking standard Lit, it's like a huge pain to have an entire, like, for example, TLS stack you have to maintain separately from another TLS stack. You're constantly taking diffs in from upstream, applying your patches on top of it, trying to figure out what you broke. So we said, how can we build a patched version of Xcrypto SH that doesn't require us to do constant maintenance of the same thing? So we went and looked at it like, okay, instead of like normally in a function, or sorry, in a file and Go, you'll have your struct and all your functions on that struct, right? Like, your pet struct. Your pet struct has like a bark or whatever, meow, or what you want to call it. And it's all usually in the same file. Well, if we wanted to add a new external function to one of those structs that we can call our code to equal SH sample things, like we don't really want to add it to that file because that's really annoying to patch. We have this, big preamble or, usually mixed into the code that's actually coming from upstream. So what we did is put all those in a different file. So we ended up basically extending all the structs that are in the base crypto library inside secondary files that sit next to them. They're in the same package. And that was a really clean way for us to basically maintain patch notes against it without having to constantly modify the same file with it there. So it makes all of our patching much easier. We're able to apply upstream patches with like one command line, the shell script here, and it's super easy. So if you do find yourself working standard Lit, I definitely recommend, instead of modifying the standard Lit code directly, create basically variants of it as like side files that basically export the variables you want, that create like additional structs that otherwise expose the bits you need to mess with. And that way you don't have to worry about constant conflicts with upstream as you're pulling patch in, especially with Xcrypto, it changes like once every 2 weeks. It's ridiculous how fast it changes. So we ended up going through and basically creating all these external versions of the internal libraries. So all the internal guts of Xcrypto SH we then exported back out as our own variables, our own structs, our own classes, our own callbacks. And it took a while to get there, but sorry, one more thing is worth pointing out here. We vendored it and we modified the package name into the package. And it's a really important part of Go that you have to do that. So we forked Xcrypto and then we renamed it to be part of run0 crypto. And then we replaced the package name automatically before we do the diff as part of the shell script. And then it's all nice and clean. That's a little bit cleaner than using a Go mod redirect in this case for a bunch of reasons. But if you have a outside importer of your library, you may not respect your Go.mod redirect internally. So it's a way to make it all nice and clean. So the biggest headache with Xcrypto is it's kind of janky. Like there's a function called shdial that does everything. So you just call that .dial function. It makes a TCP connection, does a version exchange, does a key exchange. It does all your normal crypto handshakes, things like that. Then it actually goes to your authentication message, tries to authenticate everything. Then it says yes or no, they succeeded, and then gives you a session or not a session. Well, we don't want that. We want to screw with everything in between. We don't like mess with every little stuff of it. So we end up taking the client functions, so your dial and all the stuff below it, splitting it out to a whole bunch of little micro functions that all do each individual part of it, and then we call each of those functions in our code separately and put them all back together again. So we're going to say, get to the very first phase of the version exchange, but before the key exchange, and then send this other SH command at this particular stage. So it ended up being a huge pain to go through and all that, but now we have precise control of the entire SH stack all the way through it. We also had to do things like force the socket to close in certain cases because there's a bunch of bugs in the Xcrypto library where like the channels implementation, the headache with SH is basically a multiplex protocol. So you've got Go routines on both sides kind of pulling data in, like pulling from one stream, writing to another one, and so on. So when things stall, you don't really have a good way to break it. There's actually not a context to terminate those channel reads today in the SH stack. So the Hail Mary there is you just close the socket on. Your socket's closed and everything will fall apart and get closed out. So we have to do a lot of things where we create a function that waits for a certain thing to happen in a background Go routine. If a certain thing doesn't happen, we don't call the context done on that. It then forcibly kills the socket behind the scenes. So it's kind of a brute force approach, like macheting down the Go routine basically to make it all work. But it was annoying. So the results that we created like some pretty oddball authentication functions. So our auth function here is pretty gigantic, but effectively it's a re-implemented shdial function that does literally everything from scratch. It does tracing. You can basically get it to a particular stage of the protocol. So here's the close after timeout. We've got an auth done that says if we get to this particular timeout and we haven't hit our context done, we force to close the socket to make sure we don't stall. Otherwise, our stuff just stalls forever. Not super exciting. So we go down here, we record all the permits about the protocol. What's interesting though is we basically have a skip stage parameter. So as we're going through the SSH authentication, at any point in time, we can say, we're now in this state. Should I go any further? Check my configuration. No, let's stop, let's bail out and go back. You also have callbacks scattered all the way through it. So you get to a particular phase, say, okay, now I've gotten past auth, and now I'm pre-session, give me a callback. And we use those callbacks to do all kinds of horrible things. So those are actually how we go do all the exploitation, all the fun things here. So the command stuff, like all of our auth bypass checks, we're calling these functions and saying bypass at an interesting stage. Did we get to the stage? Did we bypass SSH auth still in session? So this is labels to be like surgically attack each stage of SSH protocol in various ways. So basically bypass auth. And then when we do so, we report how we did it, create a function to let it do it again, so we can automate it all the way through. So that being a really bizarre way to implement SSH, but it works. And lastly, some gotchas. Ends up, when you work with the Crypto SSH library and every other variant of it, like Lighter Labs, SSH, or Charm Bracelet, when you create a shell, the standard in, standard out, standard out doesn't work the way you'd expect. If you treat it like a pipe and give it like a bytes buffer and say, just read this as my standard input, it will actually drain the buffer and not read the input. So what's happening is like the remote process hasn't actually started yet, and it's already draining your standard in. So you have to like sleep second, you have to like poke out a little bit, and send one byte at a time. You do all this really annoying crap to make the remote process actually get your input. You can't just treat it like a normal pipe and go. So super annoying. Another horrible thing is if we were to work with a raw terminal, like a raw TTY, so when we're doing the interactive shamble shell, we're going in raw mode. Like we're now switching into like every character we type is being processed individually as opposed to it waiting for a line of text and then reading the whole line. Because otherwise you're interacting with like a mainframe terminal you happen to hack into, right? You want to be able to navigate the terminal, you don't want to like type a line of text and then, so you need to be able to navigate the menu byte by byte basically. The problem with that in Go is that you've got all this concurrent shit happening. You've got like all your concurrent routines are doing logging. As soon as you get a shell on something, like, well now you have to only take standard input from one spot. All your standard output now has to go out a very specific outbound channel. Because when you're in raw mode, anytime you write a new line character, that doesn't work anymore. You need to do a backbar back end, not just a back end, otherwise it doesn't do the character return. So if you just do back ends, it just like scatters it like horizontally across your screen. So you basically have to create you basically have to create a TTY console proxy inside your Go code that when it's in raw mode, rewrites all your input and output and makes it all go through this particular pipeline. Otherwise your concurrent routines will screw up the terminal, it won't work right. This ends up being the biggest pain in the butt across the whole thing. It also breaks your signal handling, like Control-C doesn't work right, things go wonky there too. So there's still a couple of bugs in here, but if you're ever curious how to do like raw standard I/O, we have do all kinds of other dumb things like iTerm, for example, puts you in what's called bracketed paste mode, where if you type in if you like click a certain thing, it starts putting random ASCII garbage in your screen. So we have to do like all these stupid like terminal hacks to turn off all these bytes. So hacking all the servers on the internet was easy. Doing a freaking interactive raw TTY is a pain in the butt. So this is the hardest part of the whole thing, is make this stupid interactive TTY thing. But hopefully other folks can learn from our mistakes. So that is basically the talk. I'm sorry for going a little long there. Happy scanning. All the code's public. Open source MIT. Thank you very much.
So the website is SS. What is the website again?
Shamble with 2 S's. SSH Shamble. So like a GitHub link, things like that. Yeah, we have cool ideas for it. Going like open a pull request, like we're pretty responsive. I get like, basically buzz new type of emails to PR, get something I'm working on.
So it sounds like, I have a question. It sounds like you found like a whole bunch of like different bugs, pretty serious bugs in like random software. And a lot of those bugs, or at least some of those bugs were like commercial entities. Did they actually pay you anything for that?
No. I mean, well, I was too busy. Like, we had to talk to you. Like, I'm too old for this crap. Like, I just want to like do my research.
Well, like those guys who had like an uninitialized variable, and they basically provide them like the whole proof of concept, and then they wasted your time, like saying that they could have reproduced something that clearly they should have been capable of reproducing.
It wasn't a waste of time. They actually found a bug in our exploit. So they said, you guys are actually checking this thing out. I'm like, oh, thank you. So they actually code review for us on the Go side, which is nice. They were really cool. They actually flew out to Black Hat and hang out with us afterwards. So they were like really thankful, like, dude, because you like reported this bug, we all got to go to Black Hat. Thanks. So their whole team got to fly to Vegas to hang out with us because we reported the bug to them. And we're struggling to figure out how the whole thing worked. This is such a gnarly bug.
They should have paid for your ticket to Black Hat then.
I was already doing work there. I'm already getting paid for being out there to get exposure and things like that. So, but I mean, normally, yeah, if you're doing bug bounty program, you expect to get paid for this work. But fortunately, I don't care about getting paid for it, which means I don't have to care what the vendor says. If they say, well, we're not going to pay you, I'm like, I don't care. I put it on Twitter. Like, it's fine. Like, so most of the disclosure wars have already been one a long time ago. Now it's very much about like, can you convince them to shut up about a bug or not? And if you go through a bug bounty program and you withhold payment if they disclose it, that's one way to influence them not to stop your bug. But I don't have those constraints, and I own my company, so yeah, it's easy.
Yeah, so given all these issues and bugs, like, would you still use SSH?
Oh yeah, it's great. I mean, it's nothing better.
Yeah, true.
I mean, we use RDP, right? I mean, just doing my, like, everything's so much worse.
So the bugs weren't actually in SSH, they were like.
They weren't in OpenSH. OpenSH is pretty solid. So,
Right, yeah, they were in they were actually in software that was using OpenSSH, it wasn't actually in OpenSSH itself.
Got it.
yeah, OpenSH is like the gold standard. Like, if you take OpenSH off the shelf and you don't screw with it, it's great. As soon as you start like adding patches and messing with it and putting it on Windows, like that's when things go sideways. The OpenSH team spends so much time trying to make their code not exploitable. Like they spent 20 years just doing this. And then you have folks like Microsoft come in and say, let's just take it all out and add this backdoor to the crypto function. Yeah, you just watch them cry. I sent the OpenSH developers a link to the patch that those Microsoft folks put in, and they were like, oh my god, like really? So it made their day, but they probably cried a little bit too.
So I think it's worth pointing out that like that XC bug, right, that we talked about, like the nation state thing or whatever, it was explicitly only exploitable when SSH was linked with systemd, which it's not linked by default. So it's only linked with systemd with like Debian and with the other two, right? So if you use it like on Solaris, or if you use it like on Mac OS or anything like that, it wouldn't, it doesn't have any dependency on XZ. So that's why like it cannot be exploited for that XZ thing. So they didn't just like target like Debian because they specifically wanted to target only Debian. They targeted Debian only because it was only possible to target Debian through XZ. So
Yeah, I suspect it was that they if I had to guess, it was probably because they wanted to get into Debian and Red Hat, and that this sequence of events allowed them to do that, because like exploiting Debian and Red Hat, I mean especially Red Hat, that is a different level of money than finding something fun inside of Windows. If you found something solid and reliable in Red Hat, that is a very different amount of money than Windows. So.
Well, the code's kind of crappy, so sorry, we're in a hurry trying to get the code live for the talk, so it's a little bit of a messy job. Like,
so when did you do the talk?
We did a talk at Black Hat and DEFCON in August this year.
Oh, so like about a month ago?
Yeah, and we did like a webcast with some of the follow-up stuff on it. But this is a slightly different version of that, just based focusing on the Go side and all that stuff.
Oh, are the slides also posted on the website?
Yeah, Black Hat and DEFCON. I think the DEFCON video may go live too. So you can find different copies. There's a Black Hat slide talk more about like what is OpenSH, what is SSH, how does it work, what's the history of it, like more of the kind of like defender side, how to mitigate it, like how do you harden your system. So if you care about defending stuff, the Black Hat deck covers a lot of that stuff. The DEFCON talk is very much like shells, you know, ragdoll. So it's a different kind of conference. Cool, nice to meet you.
Yeah, thank you.
Pretty cool talk.
Yeah, yeah.
Only took 6.5 months. This is a pain. Every time off of having the last 6 months, we've gone this stupid.
Like you do.
Sounds nice.
So I am curious. So like, so these public keys were you were focusing on the static public keys, but you weren't doing like certs or anything, right? I mean, I think they're similar, like under the hood, like as far as the protocol is concerned, right?
I did what?
SSH certificates. So I think they are very similar at the protocol level. I'm not 100% on that, but
Yeah, effectively.
Is it like those PAM certificates or?
no. So
We go into a little bit.
Is it still user certificates or server certificates?
both. So you can do it on both sides. Although I mean, in your case, you weren't fingerprinting the host keys. Like, I mean, you could, but like that wasn't the point of
Yeah, that's
Jamboard.
a separate project for sure.
Yeah.
Like the bad keys project, fingerprint for those keys.
Yeah.
Looking for ones that are like weak or reused or shared or whatnot. The Black Hat deck here, these are just like Black Hat shaman leveling about like how to centralize SSH works. Effectively, you've got a central CA server that's generating short-term certificates. basically short-term SSH key. So each time you authenticate through an IDP, you get a temporary SSH key you can use, and that's basically signed and stamped by the CA that's trusted.
Is that with Vault?
No,
Ephemeral?
generally not. It would be SSH.
HashiCorp has something called an SHCA server, which is not quite Vault, but they offer a SH short-term certificate server as well.
Okay.
There's also something from Opera Software that's pretty popular. TechDia has one.
Yeah, Teleport and
Teleport.
and some of the
Oh yeah, Secret.
yeah, so some of these like zero trust approaches include SSH CAs as part of the thing. But yeah, so okay.
That's sort of the gold standard though, is like theoretically, as long as your CA key is not compromised, the worst someone can do is have a temporary access to a machine, and then they've got a backdoor really quickly in 3 minutes.
Yeah. It definitely makes me wonder, like, if you had the CA, so generally speaking, these CAs are just other SSH keys. They look the same. You just usually would set them in a way that you can SSH with that key, or even if you could, that's not how you would do it in practice ever. So you use that SSH key to sign other ones. What I think I'm not sure if there's a way that you would leak information about what keys it was expecting to see. I don't know how the protocol would leak that.
No, it doesn't. We looked at that a little bit. We're trying to figure out, like, can we guess what CA key is enabled on a given server?
Yeah.
There's no way, right? Like the timing doesn't work. It doesn't leak you information about like what CA is accepted. By the time you get to the part where it's like, it basically has to accept the key first, and then it looks at the CA information. So you basically already have to have a short-term signed key before you can confirm whether the CA cert is enabled or not. So that'd be kind of there's really nothing you can do there. From
Okay.
that perspective. What's cool about SSH keys, you can actually use it both ways. So, or the SSH certificates. You can use SSH certificates to issue a client key that you can use to authenticate with. You can also have your SSH client use SSH certificates to verify the host key. So one comparison that I'd like to make in the Black Hat deck is if you compare TLS to SSH, like what are the differences, right? Like there are very similar protocols in a lot of ways, but there's also some pretty massive changes. Here we go. So in the case of like, it's kind of like TLS, but there's not really any server key management, right? It's super kind of high chart here. So in TLS, you've got certificate authority. They issue intermediates, like you've got your root keys, your intermediate keys, and then your leaf keys, and then when you browse their website, you verify, do I trust the intermediate, and do I trust the root that was assigned to intermediate, and if you trust all of them, then you say, okay, you're authorized to tell me that this host name is valid for this key. SSH does not have that, right, unless you bolt it on yourself. So you can build your own SSH host key CA. You can also build your SSH authentication CA, but they're all separate things you have to go build. You have these third-party tools like the Opera Software, the HashiCorp Secrets Manager, or Teleport, for example, does it kind of all baked in. What's also different is like authentication is like a core stage of the protocol, and SSH was not a core stage of the protocol in TLS. TLS has mutual lock, but it's not the same as like off password, like password authentication, things like that. So SSH won't even let you get to the final stage until you technically authenticate, which is different from TLS. It's also different is that TLS does multiplexing, or sorry, SSH does multiplexing, TLS doesn't really. It sort of kind of does, you consider HB2 and ALPN stuff. And SSH also uses the very first algorithm sent by the client that's supported by the server, where in TLS, the client and server agree on the most secure algorithm. So in TLS, you've got your prioritized list of algorithms on both sides, and you try to pick the one that overlaps that's most secure on both sides. SSH has a bug in the protocol, if you will, where the server has to use the first protocol, the first algorithm supported by the client that overlaps this list, and that actually is the reason behind the terrapin bug. So terrapin allows you to basically truncate a packet inside the SSH handshake to omit part of the handshake, and that basically forces it to use a lower security algorithm by doing a packet truncation attack. That wouldn't be possible if it actually worked more like TLS, where you pick the most secure one both ways. So there's some neat differences there between TLS and SSH, but if you think of like SSH being kind of like TLS, a lot of people are actually using it kind of like TLS these days. We've got a couple examples here of like the crazy crap you can now do over SSH, which is hilarious. Like, you can watch Star Wars, of course, the whole Star Wars movie, SSH does Star Wars Tell and watch Star Wars. This is actually you guys haven't seen this, this is the best thing ever. I think I've actually watched the whole thing. So it's PDF, doesn't need animation, so I'll pop over to it. Like, No, what's amazing is they went through and they did the entire movie as ASCII graphics.
There used to be a templates for.
Yeah.
Yeah.
This is a fork of the.
Yeah, it's amazing though. So, honestly, it's the best.
But you can watch the whole movie, isn't it like copyrighted or whatever? Is it fair use?
It's considered.
At this point,
Yeah.
This is a unique creation.
Yeah.
This is satire.
That's
This
a
is
really good
like
word.
Yes. There's actually a bunch of movies on YouTube. I can't believe someone spent the time to ASCII-ify the entire Star Wars movie.
This takes a lot more artistry than the hey, let's just go re-render like the Matrix into libcaca. So
Yeah.
so you've got it's like just inside of MPlayer, inside of a terminal, and you're just using like green text, and it's like falling green text, and it's the whole movie of the Matrix just using ASCII art that's falling through the screen the whole time. And it's like, well, technically you can do that, but you know, that's not transformative?
Yeah.
Maybe?
Yeah.
But this totally was. Like, this is like stick figures and, you know.
That's
We
right.
connect to a DOS BBS, SH, there's a bunch of DOS BBS interesting to that. You can even buy coffee now through SH. Like credit card limit, you literally SH2 terminal at shop, you pick the coffee you want.
Prime Jam?
Yeah.
Yeah.
Yeah,
Very
from-
cool.
yeah.
And this is actually based on the Charm Bracelet
Yeah.
SH library, which means it has the environment bug.
You made the same thing in the browser and it's SSH. You can actually buy from both.
Oh, neat, okay. Only the SH one, but yeah.
You can do like web browsing over the internet by using like Roush or whatever.
Oh, yeah.
That works as well. Yeah. So, yeah.
What's funny about this one though is anytime you show them the shop, they know who you are based on your GitHub key.
Yeah.
Know your customers baked into the protocol. If you didn't turn off your SH agent. So what a lot of folks don't realize is when you have your SH agent added, every single server you SH to, it's going to send your pub key to first. Even if it doesn't accept it, it's going to tell you the pub key. So if you're trying to identify attackers, for example, just log all the pub keys that are coming inbound, and you'll get some random person like, oh, I'm going to hack you in SHN, and you're like, oh, you're this user in GitHub. Like, you can dox people so fast based on the inbound SH keys on the blue team side. So we set up a bunch of honeypots. I run like, all my friends were doing the blockchain. I bought the net blockchain. So I bought some IPv4 space back in the day. And I just routed all to a big darknet and captured all the traffic coming in. But for a while I was setting up like fake SSH servers randomly on it. And then logging all the pub keys being attempted just to see like what people would randomly try. And it was really disappointing. There's only like two actors in the entire internet that are trying pub key authentication attempts. And they're both security vendors doing internet scanning. Like that's just disappointing. There's more stuff in the black hat that goes like more protocol stuff in the background, but otherwise it overlaps with the stuff somewhere.
Well, we are running tight on time, so if anybody needs any of those parking passes, let us know. If you want to take more pizzas, feel free to take them, or beers, or drinks, or whatever. Whatever we don't do on the drinks, we'll just put in the fridge. Pizza is gonna go bye-bye, so feel free to take it. And thanks for coming out.
Yeah, thank you.
Thanks for hosting. Thank you for sponsoring this pizza. Parking stuff there.
Yeah, quite sure. The guys in the Charm Bracelet, he's Texas, he's from Brazil.
Oh, cool.
This guy, the guy from Go Releaser, Carlos, he's from Brazil. I've been talking to him for a while. I'm bringing him, hey, you should come here,
Yeah, just come over here.
Yeah, that would be a cool media presentation.
I love all the stuff that you like. It all looks fantastic.
Yeah.
I wish I knew how to write two UIs for them. So I'm just using some crap.
That was an awesome talk. Thank you. I'm definitely sharing this one with a couple folks tomorrow.
Sorry, it was a long too. Relative.
No problem. We're good. We're good.
Let's see. This was here before I got here, right?
Yeah, this.
Okay.
Yeah.
Do we have any security in the other town?
There's multiple. Which one do you want to know about?
Do you want
Well,
polite,
I've
rude, or
been to the one the All West one, and
Okay.
it's kind of.
Yeah, that's the lane one over there.
Wasp?
They're fine, but they're more like application testing.
Yeah.
You got DC 512, which is a little more hackery, and you got AHA, which is just like chaos.
Yeah.
So
And
AHA's fine.
then 2600, which is totally like whatever off the wall.
Yeah.
Do you go there? Do you guys go there?
Yeah, I started AHA like 17 years ago, so we've been doing it every month since. So.
Oh, really?
It's fun. Yeah, we get about, what, 50-ish people these days. It's the
Where
last,
is it?
Mr. Tramp's bar on
Oh.
183, like, it's like, last Thursday of every month. But yeah, for a while we had like 200 people going, it got too big, and then COVID and everything kind of slowed down a little bit. So it's nice being a little bit smaller again. It's kind of like Fight Club rules. If you show up, you can't talk about it, and if you show up, you have to talk.
Okay.
So every person there is given a talk, basically, because,
Yeah.
but it doesn't have to be a long one, it can be like a 5-minute one.
Okay.
And talks can't be longer than 10 minutes.
Okay.
If you go through 10 minutes, they start making chicken noises at you, and they heckle you to get off stage. So. But it's fun, like, so DC 512, 2600, AHA, of course, is fun. If you want to, for AHA, it's takeonme.org
Okay.
as the AHA song, so, yeah. We also have awesomehacker's.net or something like that, too. But,
So it started like 17 years ago, you said?
yeah, we didn't like,
Well, when did you register the domain?
some guy in China got the domain for us first. It took us forever to get all the domains together. So I think I finally got awesomehacker's.net like 5 years ago after trying a bunch. And we've been like trying to get a lot of the domains registered. But yeah, we did like Manja Pizza for a while, then we've been in Mr. Tramp's the last like 7 years or something like that. More than that probably. But it's a fun crowd. It's much more less professional. People will swear, and there's now this giant chicken that's get passed around, and someone has to take it home with them at every meeting and then put something else on it and bring it back to the next meeting. This chicken now has like laser eyes, it's got a giant 3D printed phallus, all kinds of stuff tied to it. It's got like, it's getting weird. So it's got a ball gag that's on 3D printed as well. Like people keep adding on to this weird chicken thing. So it's definitely more off color and less professional than anything else in town.
Cool.
But fun people. I think I've hired like 30 people out of that group too, so like it's been a great place to find people who like want a job in security. Plus you get these,
Does you have 30 people working for you?
over the years, over all the companies since then. So
Okay.
I started, I guess 3 companies here in town now. So,
Oh.
but I opened the Rap 7 office here. So Rap 7 bought my side project, and I opened the first 3 offices here for Rapid 7, including like, I think I left right before the Frost Tower opened, but we'd already started the process of getting that going. And then Breaking Point, which got bought by Ixia, and then running Run Zero now.
Cool. Nice.
Anything to do to help with all this stuff?
I think I'm gonna put these just in the fridge. These, I'm just gonna toss. So unless you wanna take,
Sure, I'll take
we
it.
got cheese, we got some pepperoni, and we got a little bit of margarita left.
I'll take the margarita and the cheese on it.
Okay, go for it.
Doesn't cheese, you know if it has like the blue cheese? When I tried it,
It does.
seems like
It has a little bit. It has a little bit. You
I
can
don't
usually
think it's the first time. I don't think it
I
was the
can
first
get rid
time.
of it next week, next month. I know it did. It just didn't have as much that first time.
Oh, okay.
I can get rid of it. I'm after this time. Well, actually, it was more of the last 2 times where the blue cheese was a bit much. I think.
Yeah.
So I'm thinking about getting rid of that, so I can do that. I was just trying to replicate. They used to have a fancier version of the cheese, and I was just trying to replicate what I saw that was their fancier version.
So should I take the whole thing, or do you want to take half of it?
As much as you want, or whatever. Yeah, I'm not gonna take any of it.
Oh, no, okay. I'll take it. I think like they used to make better pizza. Like back when
Yeah.
they had like different boxes, I think it was better that time, wasn't it?
I think it depends on which location.
Okay.
And the location on South Congress is gone.
Oh, it is, okay.
This is the location that's on South Lamar.
Because like this is just
Yeah.
like a
And
generic
this-
box, right? It doesn't really
Yeah.
have their name, right?
Yeah. And so the one on South Lamar, I always had more trouble with.
Slack ops.
So Charlie, if you're not gonna be here on the next side, is there not gonna be any pizza?
I'll order pizza.
Yeah, it's like if I need to order some from freaking Australia, I'm sure I'll be able to manage.
No, that's alright.
But yeah, yeah.
I can figure out pizza too. So. And my D&D off at the top, and that's like which is blowing up stores. Oh well.
Oh wait, what?
That's normal work stuff. It's like Slack is like 1,000 missed messages now.
Do you need a parking pass station?
I'm gonna grab like an Uber back.
Oh yeah, that's right.
I can walk back at this point. It's like right across the river.
Oh yeah, okay.
My Zilker's about 2 miles back, but it's usually not too bad of a walk.
Yeah.
For a while, it was like going out downtown, just running over the night, that's nice. But
Do you think Tesla's as secure?
not really. My friends, one of my friends runs used to run the what's called Antone contest. Contests every year they go out. So it wasn't like it just kind of.
I'm kind of really pissed. I have like Android, right? And on the Android, they have the NFC thing, right? So you can basically like tap the phone to unlock the Tesla.
Okay.
And I was trying to find a way to disable the Bluetooth thing, right? Because Bluetooth is not secure because like anyone can just like do the what is it called, like the receiver and like the sender attack, right?
Oh, the rebroadcast.
Yeah, the rebroadcast, right? It's like trivial, and especially if it's like if like the distance isn't high, right? Then like
It depends on it's usually the key fobs that are more vulnerable to it than Bluetooth.
Huh?
Bluetooth is a spread spectrum, so it's harder to do a replay in that sense. BTLE,
oh, okay.
It depends if you're talking about BTLE versus Bluetooth in general, but
It's BTLE. Yeah, they use BTLE for the keys.
but there's authentication stage that we're involved in.
But they can still, well, so they can replay in real time. So they can do like well, what is the name for replaying in real time, right?
Well, they have to. Theoretically, you'd have to name them. They'd have to connect to you thinking you're in the car.
Yeah.
But there's supposed to be a link key involved, and the link, there should be a cache key that indicates that you're not talking to the right person. Supposedly, not that everyone.
Well, so I think like what I have in mind is that like they can just basically have like the radio receiver and the radio transmitter, right? And they can basically like make it seem that like you're actually close to your car, right? Because the car can communicate with it.
That's for the key fobs, but not for Bluetooth.
Oh really? Why would it work for Bluetooth?
Bluetooth is spread spectrum, so it's constantly shifting what frequency it's on based on an encrypted key. So.
Well, but the spectrum is still like only 80 megahertz, right? So you can do the whole thing. Could you do the whole thing?
No, because the Bluetooth packets have a sequence number,
Right.
and if you replay it, it's not gonna work. So there's.
Well, but you're not gonna be replaying them like later. You will be replaying them in real time.
It doesn't still really work that way with Bluetooth.
Well, it used to. Like I think like it used to work for definitely, and then they patched it to make it like less easier to do that, right?
Well, I know like the 315 megahertz car fobs are easy to replay. Because you just boost the signal strength on it, basically.
Right.
You basically get a repeater close to wherever the house is, and that repeats
Right.
the signal to the car, and then unlocks the car.
Which why wouldn't you be able to do that with Bluetooth? You can just also a signal boost.
Because you're not.
Well, you boost like the whole frequency, whatever you see, like in the whole 80 megahertz. You can do that, right?
I don't think it works though.
Why wouldn't it?
I don't know. You can figure out how to do it. You know, I just don't think it applies to Bluetooth because the spread spectrum stuff.
Okay.
It did.
Well, the point is that like I wanted to disable it on the app, and there's no way to disable it. So like if you the only way to disable it is to physically disable the Bluetooth thing in the app. I mean in the phone, right? And if you I want to use Bluetooth like for my scales, you know, like for my digital scales, right? And then every time I disable it, then it enables it for the Tesla app as well, right? So I think the apps, they have individual permission, and the permission is called like nearby devices, right? And if I disable the nearby devices for the Tesla app, then what it does is that it also disables the NFC. So if I do that, then basically I cannot use the phone as like the tap key, right?
That shouldn't disable NFC though. That's weird.
Well, it does for the app, right?
Okay.
Because there's no NFC as a separate key. So I think I'm not even sure how it works, but I think basically I think basically it doesn't.
So yeah, these are all going in trash. Do we need to take them to?
And we have extra.
Just take them downstairs.
Take them downstairs?
Yeah. I'll show you guys where to put them.
Okay.
And we also have extra half pizza left. If anyone wants to take the pepperonis.
I'll take it.
Yeah,
I have been
perfect.
eating all day, so this is perfect.
There you go.
Thank y'all.
Pepperoni.
I can take you guys to.
I'll take this one home. So
Alright, yeah.
this is I'll could power through these, so.
Okay.
Are we all clean in here now? Yep. Alright. We're all done in there, I'm sorry about that.
Van a mandar a ella.
Sí.
¿Mm?
Sí. Para volverse a mí.
Andar una fotito. Eso es fácil, cuando no pueden vivir con uno, me manda una fotico. Oh. Mira que está sonando y suena y desde que te la llama.
Ay, ya venía a buscarme, a ver dónde está escondida.
No te dan quieta. Hay que decirle, déjame quieto, déjame quieta. Yo sé lo que tengo que hacer, yo soy una niña.
Bueno, eso de que no soy una niña sí está difícil.
¿Ah?
Yo soy una niña, chiquitita pero grande.
Una niña, chiquitita.
Yo majaderísima,
¿Ah?
bien majadera.
Sí. ¿Cómo sigue la niña? ¿Sí? ¿Está bien?
Ya está mejor, sí. Eso imagino, andando. Mientras no le despierre, no hay lío.
¿Y el colegio bien?
Bien. Me gusta, que es lo importante.
¿Y el otro trabajo cómo va? ¿También bien? Gratitud, que todo salga bien.
Tranquilito se ha ido.
Ay, Señor. Pico flaco.